So today we are going to solve these equations in quadratic form, and these are where we have some binomials in a place where a variable would normally be. So we're going to do something called a u-substitution here and then go through and solve it. So the goal here is to actually replace this with a singular variable to make this a lot easier to solve. So we're going to do let u equal 5x plus 3, and we'll come back to that at the end. Basically, we're going to replace every instance of 5x plus 3 with the letter u. Now we can play the x game. So we're looking for factors of negative 68 that add to negative 13. The easiest way I have found to do this is to break this up into its prime factors. Okay, so we have 17 and 4 here. That's going to work. And we're going to need negative 17 and positive 4. So this is going to be u minus 17, u plus 4 equals 0. Now that we have successfully factored this, we can go ahead and rewrite our 5x plus 3 everywhere that there is a u. So we're going to do 5x plus 3 minus 17 and 5x plus 3 plus 4. Combining like terms will give us 5x minus 14 and 5x plus 7 equals 0. Now we set both of these factors equal to 0 and we solve for x. So on this left side, we can add 14 and then divide by 5. So one of our answers is x equals 14/5. On the other side, we're going to subtract 7 and then go on and divide by 5. So our second solution is going to be negative 7/5. When we have rational exponents, the easiest way to do this is to try to eliminate what our rational exponents are. In this case, if I go ahead and I multiply everything, no, actually looking at this again, this one's going to be another u-substitution problem. Okay, so if we go ahead and we let u equal w to the 1/3, let's see how that's going to change our problem. So I can rewrite this problem like this for this exponent, 1/3 to the second power. And then this w to the 1/3 is just going to be a u. So this part right here can be a u. So our answer here is going to be 2u squared. Now let's write this in standard form. So we're going to move our 3u and move our 20. And now we get to play the x game again. This is where we multiply our a and our c term, which is going to be negative 40, and we're going to find factors of negative 40 that add to negative 3. Our factors of negative 40 can be broken down this way. And let's write them out. Okay, so what we're doing is we're taking all of our prime factors and we're listing them out, and we're going to group them together in such a way where we're going to do 2 times 20. We have 4 times 10. And I think those are the only, nope, we've got 5 times 8. Are there any factors that will give us negative 3? Yes, we have 5 and negative 8. So what we're going to do is apply the bottoms up method by taking our factors and writing them inside of our parentheses. And then we have to divide by the coefficient of u squared. So this will be 2 2u plus 5, okay, because it does not divide evenly, so we bring it up there. This one does divide evenly, so it's u plus 4. Now we still have to go back and replace our original substitution with our w. We can take this and set both factors equal to 0. And then we're going to solve for w. We divide both by 2 here. So we get w to the 1/3 equals negative 5/2. Now we're going to cube both sides here. So we have w to the 3/3, which is w to the first. Negative 5 cubed is negative 125. And then 2 cubed is 8. Okay, that does not go in evenly, so that is one of our solutions here. Now let's apply this one. We're going to add 4 over to the other side. We're going to cube both sides. So this will be w equals 64. And that is also one of our solutions here.